Hi, I'm Cheryl Leach. In this problem, we're going to be looking at the relationship between the derivatives of a couple of different functions. And this particular problem is broken into several parts. The very first part is to take a look at two functions and graph them. So the first function, f of x, I already have graphed up here for us. It's f of x equals x cubed. Okay? Now, hopefully x cubed is a graph that you would recognize. It's one of our basic forms. However, if you don't recognize it, you can always plot a few points to see what the graph looks like. For instance, we know 0, 0 is on this graph. 1, 1 is on this graph. 2, 8 is on the graph. -1, -1, and -2, -8, as for some sample points. The second graph that we're going to be considering is the function g of x. G of x is going to be the function x cubed plus 3. Right? So what I'm going to do is I'm going to take my original graph, x cubed, and add 3. What that means is all the y coordinates are 3 more values. So we're going to take the graph, we're going to move the entire thing up 3 units. So this x-intercept will now be moved up so that it's the point 0, 3. And I will do that with all of the points. So roughly this is going to look like that. Okay, so the whole thing has been shifted up 3 units. Okay. That's the first part of my problem. The second part is going to be evaluate the derivative at the point 1 for each of these. So this was part A, graphing. Part B will be to find f prime of 1 and g prime of 1. Well, in order to do this, we need each of the derivatives. So f prime of x is going to be 3x squared, simply a power rule. And f prime of 1 then is 3 times 1 squared, or 3. We'll do exactly the same thing with our function g. G prime of x is going to be 3x squared plus 0, because the derivative of a constant is 0, which means that g prime of 1 is 3 times 1 squared, which is also 3. So that's part B. Part C, we're going to sketch the tangent lines. When x equals 1 for both of them. Okay? So at 1, which will be the point 1, 1, I know that my tangent line will have a slope 3. Well, I know what a tangent line looks like. It's just going to be touching that curve. Okay? Again, think of zooming in and looking at what the rate of change will be. Let's do the whole process again for my function g. I'm going to come up to where x equals 1, which is right here, and draw in the tangent line. Okay? Notice that both of those tangent lines have the same slope. They're parallel to each other. And I could verify that they're going to be parallel because both have a slope of 3. The last part of the problem really just wants us to show a relationship between f prime and g prime. Okay? Well, we know that at x equals 1, they have the same slope, and so they're equal to each other. But look at the derivatives. Both of them are 3x squared. So it doesn't matter what the input was, the derivatives were always going to be the same. So f prime of x is always going to equal g prime of x for this particular problem. So any tangent line at any point along this curve, if you look at the corresponding point on curve g, you'll have a parallel lines. I hope this was helpful. Thank you.